Okay, so we see that we have this integral here, and we just want to integrate here. And I really don't see another way how to do this besides using integration by parts. I'll write out the formula. So we go u dv is equal to uv minus v du. That's the general integration by parts formula. So for us, we just assign things names. So why don't we let u equal x, and then we let dv equals secant squared x dx. Now you got to pick the right one. If you don't pick the right one, this integral just keeps getting harder and longer. So make sure you pick the right one. Okay, you have to assign the correct u to the correct function and the correct dv to the correct function. If you don't do it correctly, it'll become a lot harder. You may still get the same answer, but it'll just take a lot longer. Okay, well we need to find du. Du is just dx. Then we need to find v, and then if you know that the integral of this guy, the integral of dv, is just v, right? So you got to take the integral of this side as well. So the integral of secant squared x is tangent x. And you could that's something you should have memorized because you've probably taken the tangent derivative so many times, so you know it's the secant squared integral. Okay, well if you know all that stuff, then you can just put into the formula. Then what do you get? You get u v, so uv is x times tan x minus the integral, and then we see what v is. V is tan x, and then du is dx. So then we get x tan x minus ln of, I think it's ln of secant, yeah, secant x plus c. So there you go. And I purely have the integral of tangent memorized, right? The integral tangent. This is an integral I recommend just remembering because it's not an easy one to do, but it'll come up a lot. Is always equal to ln of secant x. Okay, so if you remember that, these integrals become a lot faster and simpler to do. So remember remember the little hard ones like tangents. Tangent is a hard integral, so I recommend remembering it. And secant is also a hard integral. I'll write out the secant integral. So the integral of secant x dx. It's actually very similar. It's ln secant x plus tan x plus c. So remember those two integrals because they'll save you a lot of time. Yeah, and since the video is not that long yet, I will actually do the tangent x integral here. Rewrite it. Let's start by rewriting it as we should, which is what? Sine x cosine x dx. And then you just do a u sub and let u equal cosine x. So that du is equal to negative sine x dx. So then you can do your replacements, and then what do you see? Well, you could rewrite the cosine is just u, and then sine x dx, right? This is just going to become negative du, and then this is negative ln of u, which is negative ln cosine x. And then the way logarithms work, right, with the negative on the outside, is you could factor it in, and it turns into ln cosine x at negative 1. And we all know that that's equal to ln secant x. So that's just the proof for the tangent integral. There you go.